Assalamu alaikum, Hassan Termus from Al Mahdi Schools. Today we will start by part 4 from our lesson, and this is the last part from chapter 2 in our textbook. Objectives: define absolute value, apply properties of absolute value, translate absolute value into interval, and vice versa. We need draft papers, pens, calculator, textbook, and copybook. Absolute value. Definition 1. For every non-zero real number x, we call the absolute value of x the positive number written as two dashes, and between these two dashes we put x. Read absolute value of x. Defined as follows. Absolute value of x equals to x if x inside is positive. Absolute value of x equals to opposite of x if x is negative inside here. And absolute value of x equals to 0 if x equals to 0. We can write these expressions. We can write this information in another way. Example, calculate the following. Absolute value of 7 equals 7, and absolute value of minus 5 equals to 5, and absolute value of m equals to minus m, since m inside is negative. So any positive number inside the absolute value, we keep it positive when we remove the absolute value. But if the number inside the absolute value is negative, like minus 5 and m, we multiply it by minus when we remove the absolute value. Properties. If x is greater than y, then x minus y greater than 0. So the number inside the absolute value is positive, so we keep it the same. If x less than y, so x minus y less than 0. Then the number inside the absolute value is negative, so we multiply it by minus, so the final result will be y minus x. Example 2. Radical 17 greater than 4. So absolute value of radical 17 minus 4. After removing the absolute value, we get radical 17 minus 4, since the number inside is positive. But here, pi less than 4. So when we remove the absolute value, we multiply it by minus to get 4 minus pi, since pi minus 4 less than 0. For every real number, we have radical x squared equals to absolute x equals to absolute minus x, and x less than or equal absolute x. Example, radical minus 3 squared equal absolute minus 3 equals 3 according to the first property, and absolute 5 equal 5, absolute minus 5 equal 5. Therefore, absolute 5 equals to absolute minus 5 according to the second property. Application 1. Stop the video and calculate. Properties. If x and y are two arbitrary real numbers, then we can distribute the absolute value in numerator and denominator. We can distribute absolute value in multiplication, and if we have squared inside the number in absolute value, we can put the square outside. And these two inequalities, one of them is triangle inequality, and for more information, see the textbook. Here, an example, absolute value of minus 2 over 3 equals to 2 over 3, and absolute value of minus 4x, we distribute it, the absolute value, to get 4 times absolute value of x. Application 2. Stop the video and calculate. Solving equations. Absolute value equals to r. This equation can be solved according to the following cases. If r less than 0, then there is no solution, because absolute value of x is always greater than or equals to 0. If r equals to 0, then x equals to 0. If r greater than 0, this equation has two solutions, x equal r or x equal minus r. Also, we can apply these three cases if we have a binomial inside the absolute value. Here we have absolute of x equal absolute of y. This equation has two solutions, x equal y or x equal minus y. Solve the following equations. 1. Absolute value of x equals to 3. Then x equals to 3 or x equals to minus 3, since 3 is positive. Absolute value of x equals to 0. Then x equals to 0. Absolute value of x equals negative 2. Then no solution. Absolute value of 2x plus 1 equals negative 3. Then no solution. Absolute value of 3x minus 2 equals to 0. Then we write 3x minus 2 equals to 0. So x equals 2 over 3. Absolute value of x minus 3 equals 2. Then x minus 3 equals 2 or x minus 3 equals minus 2. Solve to find x equals 5 or x equals 1. Absolute value of 2x plus 1 equals absolute value of x. Then 2x plus 1 equal x or 2x plus 1 equal to minus x. Solve here to find x equal minus 1 or x equal minus 1 over 3. Application 3. Stop the video and solve. Solving inequations now. We have this inequation absolute value of x less than or equal r. We have three cases. If r is negative, so no solution, since absolute value is always greater than 0. If r equals to 0, then x equals to 0. And this case valid only if we have less than or equal, and it is not valid if we have absolute value of x less than r. Third, if we have r greater than 0, so we can write x between minus r and the plus r. Same cases if we have a binomial inside the absolute value. Example 6. Solve the following inequalities. Absolute value of x less than or equal 3. We can put it between minus 3 and 3 since r greater than 0. Absolute value of x less than or equal to 0. We write x equals to 0. Absolute value of x less than negative, no solution. Absolute value of this binomial less than or equal to minus 3, no solution, since minus 3 is negative. Absolute value of 3x minus 2 less than or equal to 0. Here we put the binomial inside the absolute value equals to 0 and get x equals 2 over 3. Here absolute value of x minus 3 less than 2. We put it between minus 2 and plus 2 since r is positive, and we add 3 to frame x and find x between 1 and 5. Application 4. Stop the video and try. Solving inequalities. Now we will talk about this inequality, absolute value of x greater than or equal to r. If r less than 0, then x belongs to r. If r equals to 0, then x belongs to r. And this is not valid if x is strictly greater than r. If r greater than 0, then we write x less than or equal minus r or x greater than or equal plus r. Same cases if we have a binomial inside absolute value. Example 7. Solve the following inequalities. If absolute value of x greater than 3, we write x less than minus 3 or x greater than plus 3. Absolute value of x greater than 0, then x belongs to r minus 0. All the numbers are accepted here except 0. Absolute value of x greater than or equal minus 2, x belongs to r. Absolute value of 2x plus 1 greater than negative 3, then x belongs to r. Absolute value of this binomial greater than 0, then x belongs to r. Absolute value of x minus 3 greater than 2. Since 2 is positive, we write x minus 3 greater than positive 2 or x minus 3 less than negative 2. Therefore, we can get x greater than 5 or x less than 1. Application 5. Solve the following inequalities. Now, absolute value and intervals. We have this table where C represents the center and R represents the radius of an interval. I have only one remark here. If we have less than or equal, we have a single interval. And if we have a greater than or equal or greater than, we have union of intervals. And you can apply these rules. Example 8. Write the following inequality in a form of interval. Here we have absolute value of x minus 5 less than or equal to 4. Then c equals to 5 and r equals to 4. Then x belongs to 5 minus 4, 5 plus 4 means c minus r, c plus r. Then x belongs to 1, 9. Here we close the interval since we have less than or equal. Here, absolute value of x plus 1 greater than 10, then c equals to minus 1 and r equals 10 according to our formulas. So x belongs to minus infinity minus 11 union 9 plus infinity according to the formula. Application 6. Stop the video and solve. And finally, this is your assignment, and here's a summary of the first part, second part, third part, and this is a summary of this part today. And thank you for watching. Wassalamu alaikum.